Today we're on day 4 of our CMS webinar, and today we'll be talking about CMS Wave, which is the Wave companion model for CMS Flow, which we set up in yesterday and the day before. So today we'll first go through the presentations just to give us a primer on how we generate the CMS grid, and then the wave spectra and the model control, which are used to force the files. We also have some information on coupling CMS Wave and CMS Flow, so we'll get to that today. And then once we get that overview, I'll actually go in and do this, and folks can follow along either now or later when these videos are posted. Okay, so we'll start with the same clean slate together. We'll load the project from the previous workday. So if you look in the day 4 files, we'll start with the folder 1 after day 3. And then when we do that, we can see all of the information from our CMS flow. And if we were to open up this little plus for the simulation data, we would see the CMS flow simulation. To get started with creating our CMS wave grid, we need to create a new coverage. And so that's the first thing we'll do. CMS Wave has its own type of coverage, so we'll highlight that and say OK. And then as we created a grid frame for CMS Flow, we'll do the same thing for CMS Wave. So we've got the same purple square down here. You do need to be careful. This is one distinction about CMS Wave that is not the same as CMS Flow, but you have to start at the offshore corner of your grid and then move onshore. And that's just because CMS Wave is numbered in that order, and all of the coordinate transformations that happen are relative to the grid corners 1, 2, and 3. So just be careful with that. And you may be worried, oh, well, how do I know I'm clicking the right way? What if I forget? Once we get into the model control, there is a way to check yourself to make sure you did this correctly. So in the same way, as we did before, once this grid frame is created, we can then click on it using the grid frame selective tool, and that allows us to resize it and rotate it. And again, make sure you save frequently as you go along. So if we want to, we can actually specify the origin point and the size of our grid. And what I highly recommend is that you make this the same size of your CMS flow grid, if that is your plan. If you're going to be running a CMS grid, CMS flow and wave in the coupled mode for extrapolation purposes and making sure there's continuity in the boundary conditions and that information is properly shared, it's best practices to make them about the same size. And there's a note here that the backside does not need to match the flow if the wave energy will most likely be dissipated. That is true. So for example, if we think most of our waves will be totally dissipated back here, if our CMS flow grid extends a little further up, for example, if there was a river flux boundary at the top of this grid, we wouldn't necessarily want or need the CMS wave grid to extend as far back. Okay, someone asked a question yesterday about how do we control the refinement of the CMS wave grid, because it is unlike the quad tree grid for CMS flow. We have a different type of telescoping type refinement. So what we do is we create refinement points, and that's done in the same activity coverage or map coverage. So, we can see that CMS wave is highlighted here, meaning we're actively working in the CMS wave coverage. And so we've already created the grid frame generator, so the option is to select it. Now what we're actually doing is creating these feature points, and we'll create some here and here. And those generally are your banking points of where you want your refinement to increase towards, or your resolution will decrease towards that. Grid cell size will decrease towards those feature points. So you can see here, once we have those, we can right-click them and define the refinement in both I and J space, which is if the grid was rotated to 0 in Cartesian space, that would be X and Y. And you can do that in one or both directions. And so this refinement starts as a feature point and then increases outward, as we just mentioned. So now when we're ready to make the grid, it's a little more faster in that we don't have to create all of these arcs that become polygons that have specified grid cell size. All we have to do is identify these refinement points and then move into the grid generating tool by right-clicking the map property and saying convert, and then we'll convert that to a grid. And you'll see that option when I go through the demo, although it looks like it's blocked out here. Although maybe that's just the default convert tool. Anyway, oh, I see, convert map to 2D grid. Okay, so back to our refinement points. In these red boxes, you can see this is where we can define we want the maximum cell size to be, and then either choose this inner growth option and define the bias. And the bias is what defines the rate of change between these grid cell sizes from the maximum to the minimum. And then inner growth, we'll see in the next few slides, we have examples of what those options look like. And again, don't forget to select your scatter set for your bathymetric depths here. Otherwise, you'll create a beautiful grid with the resolution that you want, but no depths, so there will be no waves. Okay, so when the inner growth is unchecked, that means that you can only have growth in one direction. So your cell size will be monotonically decreasing towards the cells, excuse me, the refinement points. But if you leave that, or excuse me, if you check that, you can see on the right-hand side, we have growth in both directions, or both the outer and the inner directions. So that's how we get the variable grid cell sizes in both X and Y in both directions relative to that refinement point for both of them. And you can have inner growth checked for one and not the other, and vice versa. So bias, this is what the bias tool does. So you can see a larger bias value will increase your rate of change in grid cell size between your smallest and your largest. Okay, now that we have a grid, we need to apply some forcing for this grid. And we do that by defining a wave spectrum. So in order to do that, we need a different type of coverage, and that's called the spectral coverage. That's a generic coverage because the spectral feature is used for other models that CMS keeps on their repository in the working space. So first, what we need to do is add a feature point for spectral information, which is typically what you would. There's a few ways to do this. If you have one that's representative of your whole boundary condition, then you should put that roughly in the center of your domain. However, you can have multiple. So for example, if you have a buoy located in this corner of the grid and that corner, you can have two, and then you would want to obviously put those feature points as close as possible to the actual buoy locations. Okay, and then for each one, we select the point and click on nodal attributes, and that will generate or pull up our spectral input dialog. So the first thing you'll do is click up in the corner, create grid, and that will create this sub dialog about the attributes, specifically the grid angle. And the value 167 is automatically defined by SMS. What it does is it goes back to your model control, or excuse me, your CMS Wave grid, and it looks at the orientation of that grid. So it assumes that you want a spectral grid that is equivalent in orientation and angle to your computational grid. So the next thing we'll do is hit OK, and that will provide a spectral grid. And I don't see, okay, the next thing we're going to do is we have by default some parameters of what the spectral grid looks like in both angle orientation, so the number of directional bins, as well as frequency bins, but that is something we can change. And to play with some of those features, we look at this tool, the spectra. So what exactly do we want our spectrum to look like? So we click the spectra tool, and this generate spectra comes up, and we have a few options for generation method. By default, the one at the top is TMA, which is used for shallow water. You can change the angle of the grid. So for example, if you pulled a grid from NOAA, and that is if you pulled a spectrum from NOAA, a directional spectrum, that may be in meteorological coordinates, or maybe you already converted that into nautical space. So instead of converting that again to a shore normal coordinate, you can just select oceanographic. You also want to make sure you tell the dialog box what the depth of your boundary is, and that it uses that information to propagate the model forward. And there is a little bit of a redundancy there. Obviously, your grid is going to have that information, but for some reason, historical reasons, we still have that feature there. I guess it is possible you could specify a spectrum that is taken from buoy information that's maybe deeper than your actual computational depth at the boundary. So that's just something to keep in mind. Anyway, for this work, we're going to use the import option for our spectrum instead of defining that manually, although you can do that. So where is that? Okay, so the import button is here. Sometimes we have to remind ourselves where the buttons go between different versions of SMS. So we'll click import, and then that will pull up our dialog box, and we have a spectral file with the extension ENG in today's files under day 4, wave spectra. There is a minor bug right now in the SMS dialog where this import tool will only highlight files that have a .txt extension. So the ENG file, which is what you can get out of the WIS portal, for example, it is a text file. We just give it this .eng extension for historical reasons. That way we know exactly what it is. But you should easily be able to change the extension just manually in the file browser from .eng to .txt. Okay, This is an example of how you might prescribe these manually if you wanted to, for example, with a John swap spectrum. And you can either prescribe the directional spreading distribution as either the wrapped power method or as a cosine power. So there's some slight distinctions there, but typically what you can use for those directional spreading parameters, unless you know that they should be something different from the default, we do have some spectral defaults. So that's specified with this gamma and n, double n parameter. And so if you hit spectral defaults, it'll tell you, okay, for a wave period of about 10 seconds, you should use a gamma value of 0.33 and a double n value of 4. And that's the lower limit of the range of the John swap typically with those directional spreading parameters, or beyond that point, directional spreading maybe isn't as important. So we just use 3.3 for gamma and 4 for double N for wave periods less than 10 seconds. Okay, the last thing you need to do before moving out of the spectral specification dialog entirely is you update your reference time so that when you begin to run the model, you might think you're running in days following January 1st, 2000, but your spectrum may be in a different time. So the model has to be told that these forcing conditions and the simulation themselves do overlap. So you can see the output of this dialog here, I think, is what I've used to generate this spectrum here. So this is our directional spectrum, and you can see the energy is distributed down in these kind of lower frequencies, or rather not very high frequencies, and the rotation and the angles kind of indicate this is your grid angle orientation. So it's the distribution of energy relative to that dark line indicates where the waves will approach relative to your grid angle. So that's a visual opportunity to check to make sure you are confident and happy with the inputs you provided. Okay, now that we've done that, we move to the CMS Wave model control. And we do that by now creating a new simulation. So you can see under simulation data, we have CMS flow, which we did all of yesterday. What we've done here is you can right click under simulations and say new simulations and then CMS Wave. So the first thing we'll do is we'll add our CMS Wave grid to the simulation. We'll right click that and see the CMS Wave menu option appear. So we'll choose model control, and then we'll get a dialog that looks like this. The first tab here is different parameters, and the second option tab is boundary control. So again, it'll take some kind of default information, the frequency distribution in number and the size of those bins. And here we can see that by default, CMS Wave has given itself a side 1, side 2, side 3, and side 4. And that's why when you create the CMS Wave grid, you have to be careful about your first corner of the grid, because you can only prescribe information in CMS Wave on side 1, or side 1 and side 3. So that's here and here. So if you know that your grid is about this shape and you see side 1 over here, then you know, well, I can only specify side 1 and waves don't approach from that direction. So obviously something's wrong. So that's a way that I check myself to make sure that the CMS wave grid was created properly. Okay, but since we did it correctly, we now have side 1 and we can use the specified spectrum option, and we will hit select, and that will allow a pop-up of the map data that is applicable to be applied here. And we only have one, and that's the spectral forcing condition that we just created. So we'll select that. And again, don't forget to set your reference time. Here under case data, you'll also see under case data the option for wind direction angle convention as either shore normal or oceanographic or something similar, or Cartesian. And you can also populate the wind information from your spectra, if it's in the spectral map coverage, into the dialog down here where we have time, wind magnitude, and wind direction. A few other things that you control before you move into setting this CMS wave simulation into motion. You can define as either half plane or full plane. Half plane is computationally much faster. However, if you're in an area or a simulation where you know you're going to have a really strong reflection, you may want to consider using full plane. And that plane is not necessarily the frequency plane, but the directional frame. You can either compute waves over 180 degrees or the full 360. You can either have current information turn on or off. So if we were running CMS Wave in standalone, but we had currents that were simulated from some other simulation, we could link them here, and the same with surge. Wind fields, we can have variable, spatially variable or constant, and we can also control the number of threads here. But once we're happy with all the options we've selected, and I've noted in some of these other output control options and tab 4 options, there are things like using fast mode on or off, or the wave breaking type, or wetting and drying, turning that on or off. So we want output of the extreme run-up elevations. So once we're happy with all those options, click OK. And now we run the simulation. And we do that by right-clicking down here. It says CMS Wave Simulations. And I think if I go back, yes, we can run a model check to make sure we haven't forgotten anything, missed any steps. It's kind of like when you're filling out a form online, there's a little asterisk that won't let you continue until you do that. That's kind of the value of the model check. You can save your simulation to run at a different time, or if you want to run it in the command line, or you can do all three at once by saying save project, simulation, and run. And that's the one that we use almost, not exclusively, but we do that quite often. And in the new SMS 13.3, it gives you the option of checking a number of simulations, however many you have. You can either say all off or all on, and then that will help you select the simulations that you are interested in running at the time, and then hit OK. And if everything's working correctly, then you get to see some average wave heights that are non-zero. If you get all zero, something's wrong. We don't exactly have a residuals plot tracker here like we do for CMS Flow, but it is helpful to just watch the command line output. Okay, so before we get into the next portion of the presentation, maybe now is a good time to stop and ask questions. And let me make sure I can see. How do I want to see the chat box. Maybe I can't. Oh no, here it is. Yes. Okay, great. Any questions?
Yeah, Sophia, go ahead.
Yes, this is Mark. I'm with Sophia. Could you go back into the, I know we're not doing cell splitting, but the refinements, that's kind of very important to us. And is it possible to do several areas of refinement?
Yes. So you can add as many of these model feature points as you desire. So in this case, we have 2, but that's totally up to you.
So like if we have a field of structures, breakwaters, but we would like to get when we do a morphology change, we'd like to get some detail, increase the level. In the past, we used to split the cells in those, manually. But in this case here, would we need to use 2 points like you have here, or just put 1 point at each structure?
That's a great question. I think it depends on the orientation of your structures. What does the shoreline look like? Is it kind of up and down uniform like this? You can see if we change the position of this refinement point that was very close at this inlet, we would have high resolution in both X and Y space all along this shoreline. So that is a process of trial and error. It really does depend on the features that you care about and their relative position of the shoreline and the points. And it's very quick. It's a very quick process to play around with these different points, whether you check inner growth on or off. So I highly recommend you kind of play with that. And then each time you do it, look at those features that you care about and say, okay, what is the actual resolution here? Because once we do this, we can zoom in on the features and use like the little measurement tool to see what is the exact resolution in the area that you care about. Is that helpful?
We cannot undo, right? So once we start going,
Correct.
adding cells, if it doesn't work like we want, we
Yeah.
have to kind of start over.
Well, there's a few ways you can do that. You can, yeah, you can just delete a feature point and do it again. You can create many of these CMS Wave grids. You only add 1 to your simulation. So again, it's a very quick process. So adding a point, doing it again, removing a point, doing it again, it can all be done fairly quickly.
That's what I was going to mention is what we typically do is we'll do this once, we'll create a grid, we'll see it's not good enough, we'll go back and change and add points, and then we'll just create a new grid. And creating those grids is really, really quick. And so we can, do this several times, iterate back and forth. Well, we've had some grids where we do have a lot more than just 2. This is just a simplified example for this course. But typically, if you have bends in a river or things like that, where you might want to increase in several different spots, just make sure you put the refined points in those locations. Also, your structures, like you were talking about, just know that wherever you have a refined point, the resolution will be whatever you specify at that point and then move out from there. And so there may be occasions when you have multiple of these points that they kind of interact with each other. So you may have 2 points defined in totally different spatial areas of your grid, but in the eye direction, they're relatively close. You may end up with, more resolution than you actually want in that spot. So you just have to kind of look around and see what happens when you add these refined points.
Thank you.
Sure.
Okay, thank you for that. Does anyone else have any questions before we move on?
We're going to go through and do a demo of this later too, and then we can answer more questions as that comes up and, show a couple of different iterations of this.
Yep.
Yeah, this is Li Hua Ling. Sometimes I think, you can go through those pair feature point, do the refine, those I think cell resolution. But sometimes, if you, only change a little bit, you can split, the cell. You can do that in X, in Y direction. The tool allow you to do that one. The only thing, if you split the cell or you merge cell, sometimes it messes up your bathymetry. So before you do that, make sure you need to map your the scatter point, again, to your grid. Yeah. Over.
Thank you, Liwa. That's a great add.
One thing I will say, in the new interface, I don't believe there's an option for splitting anymore. Looking at it right now, I see only cell selection, create a new grid frame, putting in a contour label, and one other option. So I don't think that splitting is available anymore in 13.3. And so it all falls back to these refine points and adding them exactly where you need them.
Okay, that's good to know.
Yeah, one of the problems with splitting and doing these refinements after or outside of the map module is that if you ever wanted to recreate that exactly, there'd be no way. You'd have to, you might not get it exactly like you had it before. And so doing it in the map module with the refined points allows you to recreate a new grid exactly as you wanted. So anyway.
Okay, good to know. Yeah, I know. Yeah, earlier version you can split, you can drag, right? Change those position. Yeah. Okay, good to know.
Okay. We've run CMS Flow. We've, in theory, run CMS Wave. Now you are probably thinking, well, how do I do these at the same time? I obviously want to include wave radiation stresses and mean momentum fluxes in the flow simulation. And we know that flow speeds and directions can influence your waves. So to do this, we couple them through the process called inline steering. And steering is maybe not the word that you would typically use. Sometimes or other models use coupled in their terminology. But if you think about it, the steering is kind of a correcting of the flow towards a wave solution that makes more sense, and vice versa. So they kind of steer your simulation along, and they share computational time. So we move from a wave time step, or CMS Wave will move along until our steering interval. And at that point, you'll switch between flow and wave. And so that computation of both interchangeably is what adds to a more realistic solution. And you can choose that steering gradient, or excuse me, steering coupling time to something that makes sense for your simulation. Maybe you're looking at flow conditions that never change. Maybe you don't even have tides. Maybe it's just stream flow. But then you maybe need or don't need a really short steering interval. However, if we do have tides or some kind of storm event where we have fairly variable flow conditions, you want that steering time to be at least about like 30 minutes to an hour. Okay, next slide. Okay, so we control this coupled flow and wave simulation in the CMS flow model control. So you can see that's the dialog box I have open here. And then we want to move to the waves tab. When we do, by default, this is off. So we'll select that drop-down menu and see we can either use this single wave condition, which might be useful in some circumstances, but generally when folks are using this, they want something that is more dynamic. And that is what gives you more realistic wave results as well as the flow. So instead, we use inline steering, and then you define the steering interval here, and you now select your CMS Wave simulation file. But you'll notice that you can only find this folder in your directory if you've already saved a CMS Wave simulation. So even though you may have all the components of your wave simulation ready to go, if you don't first go through a model checking and then saving of those files, it won't export this wave grid.sim file. But once you do, you should be able to find that, and then we'll select that. And so you can see where we just pulled that CMS Wave simulation file. Here we have a 3-hour steering interval, although we probably want something a little less than that. And then we set the extrapolation distances. And we generally recommend that you minimize those as much as possible. And if you don't know what an appropriate value would be, you can set that in the automatic option, and it'll take care of the extrapolation for you between the two grids. But again, best practices is in the space where you have both CMS, where you expect waves and flow to exist in real life. So especially in your open offshore portion of the grid, you want those grids to be as close as overlapping and equal in size as possible. Okay, that's really it for the dialogue for the CMS flow and wave together. It's really straightforward once you understand how to set up CMS flow and CMS wave.